So we can let the density and also the velocity of the liquid at point P is equal to rho, as we try to see. And also this is equal to rho and also is equal to V1. Now we should go and try to observe here. So the mass flux past P is given by this one. As we when we record the mass per second, we say that the rate of change of mass will be represented by this formula that you found through the pipe, my dear student. Now we can take the mass and express it in terms of density and also in terms of the velocity and the cross-section area. Now we know that the mass, my dear student, must be equal to the density times the volume. Is equal to the density times the volume. But how can we get the volume? The volume, we must take the cross-section area, then we multiply it by the distance. Now, as you can observe here, that at one end, we should obtain the rate of mass. The rate of mass must be equal to the small change of the bracket. It means instead of writing this mass, we have tried to substitute the formula of getting mass in terms of the density and also in terms of the cross-section area and also the change this distance. Now we should say that is equal to the small change bracket density 1 times the cross-section area. We multiply by the x1. This is a distance that you found at one end of the tube. Then it divided by time. Now, if we simplify, if we open the bracket, because the density can change and also the cross-section area can change. Now, this distance could be very small because we take the pipe and that contain the amount of liquid and try it to apply the pressure so as to push those liquid to squeeze at a certain distance, as we try to see. Now we should obtain equal to density 1 cross-section area 1 bracket the rate of change. It means the small change of the displacement divided by the small change of time. If we simplify more, we obtain that this is equal to density 1 times cross-section 1, then we times by V1. Kwa ndo namna ambavyo tutaweza kuexpress, na hapo tutasema kwamba kumbe the rate of change of mass, my dear student, must be equals at one end. It means at one point, at point P, as we try to see at point P, we have area 1 V1 and also the small change of this one. We should express equals to density 1. We multiply by the cross section area 1. Then we multiply by the V1. This V1 represents the velocity, the rate of change of the displacement, as we try to observe. So likewise, and that point Q. Let us come for point Q. At point Q, we will use the same way, the same formula by recalling the rate of change of the mass, and we should obtain that the rate of change of the mass must be equals to the density 2 times velocity 2, then we times by the cross-section area 2. Instead, this is the rate of mass that of the liquid that living at point Q. Kwa tutapata ni sawasawa na density 2, then we multiply by the speed, then we multiply by the cross-section area. This is how we express the rate of change of mass at the point Q. So after this one, now let us label equation here. We should conclude by saying that if there are no leaks along the path of the liquid, the mass flux of the compressible fluid at point at P is equal to the mass of the flux at point Q. Kwa sasa tutakachoenda kukifanya ni kwamba kama if there are no any leaks, as we said as we tried to explain that the mass of flux of the compressible fluid at point P ni sawasawa na rate ni sawasawa na mass of flux at point Q. The way we can't express it, my dear student. Now, we were supposed to obey the principle conservation of mass so as to explain the law of mass continuity by saying that rate of mass of the fluid at point P must be equal to the rate of mass at point Q. Now, we have obtained the rate of mass at point P, which is equal to density 1, cross-section 1, A1, then we times it by the velocity or the speed 1. For the second pipe, for the point Q, now we should substitute equals to the density cross-section area 2, we multiply it by the second speed. Now, if we equate, we should obtain that this cross-section area 1, we multiply it by the speed 1, then we multiply it by the density 1. It must be equals to the cross-section area for the point P at point Q. Then we times it by the second speed, we times it by the second density, as we try to see here. This will be our 5. This will be our 5.2 equations. Kwa hiyo itakuwa ni equation yetu ya pili kwenye topic yetu ya 5. So for incompressible fluid, rho 1 is equal to rho 2. Now here, as we tried to see on the last session, we tried to explain about the compressible and also incompressible. For a compressible, we say that for a compressible, the density must change, the density must vary. But for incompressible, the density of the liquid at one point must be equal to the density of the liquid at the other point. Now, we say that this density, this rho 1, this means the density 1 must be equal to density 2 for the incompressible fluid. And this, the remaining one will be A1 V1 must be equal to A2 V2, and this will be our third equation for our 5 topic here, as we try to demonstrate here. So equation number 5.3 here is known as the mass of continuity. So this equation that is obtained for incompressible fluid, where the density 1 is equal to the density 2, and the remaining one, this density cancelled out because they are found on both sides. Now the remaining, this equation number 3 here represent the mass, the law of mass continuity. Kwa hiyo hapa ndio inaelezea kuhusu law of mass continuity. Now for incompressible fluid, the product of the cross-sectional area A and the velocity V of the fluid at any point in the pipe is a constant. Kwa sasa tutamwambia sasa kwamba kwenye incompressible fluid, huyu cross-section area pamoja na velocity should remain a constant. Kwa wale wata remain constant, mwisho wa siku sasa tutamwambia this AV must be equal to the constant because it change. Either must be equal A1 V1 must be equal to A2, V2 must be equal to A3, V3, and so on. So this must be a constant. And this constant is called the volume flux and the volume flow rate. Kwa hiyo constant sasa tutaita ni volume flux. Kuna maswali mengi ambayo anakuwa anakuuliza ku-explain about the volume flow rate au the volume flux, the volume flux. Kwa utamwambia volume flux ina explain that the rate of the volume at one end must be equals to the rate of the volume at the other ends. So by saying that, this will be the end of our session here. Now I would like to welcome you again for another session. I wish you all the best. Have a nice moment.